Hi, welcome to the start of a new chapter, Chapter 3, Exponential Functions. In this video, we're first going to do some fun activities to introduce us to this new topic, and then we'll get into 3.1, Exponential Growth. Okay, our first activity is to imagine that we've just been hired on at a prestigious law firm. Okay, and they've given you two options for salary or for payment. Two glorious options. Okay, the first one is a monthly payment of $40,000. So not too bad. Every month you'll get a check for $40,000. Option two, okay, this one's a little bit different. So on the first day, you're paid 1 penny, and on the next day, you're paid 2 pennies, and each consecutive day, the amount doubles. So then 4 cents, 8 cents, 16 cents until the end of the month. Let's say it's a nice juicy month of 31 days, okay? 31 days total. So you're going to start with a penny, and then 2 cents, 4 cents, 8 cents, 16 cents, and it's going to double each day. And then at the end, you get that total amount, okay? So go ahead, pause the video, try to think of something clever to figure out what choice you want to make, okay? And this is real money we're talking about here, so don't nonchalantly choose one option. Um, so yeah, I'll let you pause the video, and then when we come back, we will discuss both of the options. Okay, welcome back. I'm kind of curious what you guys maybe might have done to try to come up with what option to choose, being math students and all. Hopefully we didn't just kind of guess, but hopefully we try to arrive at a certain value. Okay. So if you just played it safe and you picked option one, well, you're going to get $40,000 each month, which isn't too bad. However, you would miss out on a good chunk of money. So um, option two works out to be much more beneficial. Okay. So if you picked option one, then it just cost you, or in other words, you just missed out on this number right here. So over $10 million, okay? And no, I did not make a mistake when I put that down. Okay, so when numbers are able to double, they can start growing really, really quickly. And it doesn't take too long for that to happen. So yes, it's very little getting just paid 1 cent, then 2 cents, then 4 cents, etc. But that pattern does start to grow. Um, so let's just talk about how we can kind of come up with this number. So like I was saying before, I was a little bit curious to see what you guys might have done, but you probably might have seen that when you double a number, it does start to grow really quickly. So I think the best way to look at this would probably be like an Excel sheet. So I know you probably wouldn't have chosen to do this, especially if you haven't really used Excel or you don't like Excel. So it is kind of a very powerful tool, though. What I've done here in this column on the left, I just have the number of days for the month. So day one, day two, all the way down to 31. So it's 30 day, 1 month. We started with 1 penny. What I'm going to do is I'm going to tell each cell, so I got to double click on it. I'm going to tell each cell to be equal to the previous cell times 2. Okay, so when I do that, it's going to take the cell just above it and multiply it by 2. So in this one, it'll be 0.01 times 2, giving me 0.02. And what makes Excel powerful is I can double click on this, if it works. Okay, there we go. And I can hit fill, and then I can drag this down, and it's going to apply this rule. So I'll go to about, let's say, 10 days. So on the 10th day, we're making only $5.12. Not that big compared to 40,000. Okay, but now let's continue to drag this. Okay, and we can see those numbers are starting to get big quickly. On day 20, we're getting paid $5,000. And that's going to get to double. Okay, I'm going to drag it out a little further. Day 26. Okay, let's go to redo this. The fill, day 26. Day 26, we're making $5,000. That's not even including the money that we made before, the 167,000, the 83,000. I actually didn't include that in the total that I did on the slide. Okay, and I know you guys are curious to see what happens when we get to the end. So day 31, just including day 31, you're getting paid $10 million. You're not even, that's not even including the 5 million you made the day before or the 2 million. So if we want to add this all up, okay, if you chose option one, you're probably crying a little bit right now, but that's okay. Um, we'll add the sum in here. So it's a total of $21 million and 47,000. So you actually would have missed out on about $21 million. So um, that 10 million that I said before wasn't including all the other days. That was just the 31st day. So even if the month was small, like a 28-day month in February, you would still be making over $1 million just on that day alone. Okay, let's go back to the PowerPoint. So maybe you might have done something like this. You might have took Desmos and you might have started with 0.01 and then just cut multiplying by 2, right? Like 30 times or 31 times. You could do that. You might notice though, when you keep saying multiplying by 2, you could rewrite that as a power. So you could write it as 2 to the exponent. And since we started with 1 penny, that's going to double 30 times. So we could write to the exponent 30. And that's how we get that other money, that amount that we had in the Excel table. So this doesn't give us the total, but it does let us know quickly that this is definitely a more beneficial option. Anyway, I hope you enjoyed that activity. We're going to do one more. So it has to do with folding a piece of paper. So get out a sheet of paper. It could be any size. It can just be your typical lined paper or even printing paper. And I want you to see how many times you can fold it in half. Okay, so if you're pretty good, you'll get like 6 folds in half. Okay, and I'm talking about honest folds too. I know when it starts to get small, it's really hard to fold a sheet of paper. So if you're really good, you can get maybe 8. Okay, so if you need to pause the video, you can. And then when you come back, we'll talk about why it's so hard to fold it so many times. Okay, so welcome back. And I'm not sure how many folds you were able to get. If you want, you can leave it in the comments below. But you can see what our Guinness Book of World Record actually is. This was as of a few years ago, so maybe it might have changed, but the current record is 12 folds, and it's with this ultra thin sheet of paper. So I don't know how they get 12 folds. To me, it seems impossible because the amount of area that you're folding starts to get really small, and also the thickness really increases. So why is it so hard? Well, each time we fold it, the thickness actually doubles. And we kind of seen in the last activity that when you double something, it grows really quickly. So the amount of sheets that you need to fold goes from 1 to 2 to 4 to 8, 16, 32. So that's only 6, 64, 128. So if you do like 7 folds, you already have like 128 sheets of paper, and then you need to fold all those. And the area, not only that, the area is halved. So that's also what makes it smaller. Every time you do a fold, you have half the amount of paper to work with to try to do a fold that's twice as thick. So now I'd like you to try to visualize something. So now we've kind of seen what it's like folding a piece of paper. Imagine you could fold a sheet of paper 50 times. And imagine that sheet of paper is only 1/100th of an inch thick. So take an inch and divide it by 100. That's how thick it is. That's actually typical paper size. Okay, so downstairs in our photocopy room, we have stacks of paper for the photocopier, and a stack of 200 is actually 2 inches thick exactly. So that means they are 1/100th of an inch thick. So if you had a piece of paper like that, And we'll kind of say it's like special paper. So not only does it have that thickness, but you can also fold it as many times as you want. Okay. So assume you could fold it 50 times. Okay. I know the area would keep cutting in half and there would basically be nothing left to try to fold, but imagine you could do it 50 times. How high do you think that would be? Okay, so do you think it would work out to about like a foot tall, maybe, if you could fold it 50 times? Or maybe like as tall as you, maybe about like 5 feet or 6 feet tall. You think it's possible to reach that height, folding a piece of paper 1/100th of an inch thick 50 times? Okay. Do you think it could be even higher than that? Okay. Do you think it could be like maybe like as tall as your house, maybe about like 30 feet tall? Is it possible for that? Okay. Do you think it could actually exceed that? Do you think it could like maybe be as tall as a football field? So football field is just over 300 feet in length. Do you think it could be 300 feet tall? Is it possible to reach that? Okay. Could it even exceed that? Could it reach like maybe heights that only planes would reach? Okay. Could it actually reach the outer layers of our atmosphere? So like the stratosphere? Is that possible? Could it reach where maybe altitudes that satellites orbit at? So outside of our atmosphere, is it possible that it could be that tall? So all those analogies, they might sound really, really ridiculous. And I know that this activity is really hard to visualize, but if you could fold that sheet of paper 50 times, it would actually totally exceed all those distances that I mentioned. So it works out to, if you're ready, if you want to pause it and try to calculate it, um, I think it'd be kind of fun for you to try to figure that on your own, but I'm going to show the answer. So it's going to be this many miles, 200 million miles high. That's how thick that folded piece of paper would become. 200 million miles. Okay, that's ginormous. That's actually enough to go from Earth, the surface of the Earth, to the surface of the sun and back again. Okay, that's how high that pile would become. Imagine if we folded it one more time, it would do that again. It would go to the sun and back 2 times. So it shows you how doubling something it can grow really, really quickly. Uh, if we look on this Excel sheet, you can see that at 31 doubling patterns, you could say, our number is already 10 million, and then 32, it's 20 million. Well, if this is allowed to double until 50, you can see the numbers will just get really, really large, and too large for Excel to even post because there's too many digits. Okay, going back here, we can actually see the number 2 to the exponent 50 is a massive number. It's got 16 digits and just 2 times 2 to the exponent 50. There's 16 digits in that number. So when you multiply that by 0.01 of an inch and then convert that to inch to feet and then convert the feet to miles, you then get approximately this number right here. Okay, so that's it just for activities for now. Just to show you the power of exponential growth, the power in doubling something. Its growth rate far exceeds all other functions. Okay. All right, so that's it for this video, and I'll see you in the next one when we start beginning 3.1 exponential growth. I'll see you later.